All right, so we're going to be working on variables on both sides today with solving equations. As we get started, we're going to have to keep in mind that we're going to need to try to simplify to two terms on one side and two terms on the other. We've been doing two on one side or one on the other, or one and two. We're going to shoot for 2 and 2 before we start moving things across to the equal sign today, okay? We kind of touched on this on the last video in terms of how do we handle variables on both sides, and I know that many of you have seen this last year. So hopefully this is just review. But let's go ahead and take a look at this guy. So in looking at this problem, hopefully the first thing that you notice is the distributive property. So why don't you go ahead and take a minute, hit pause, see what you can do with this do now today. And remember, if it's a fraction, then simplify it down. But go as far as you can. If you get stuck, I'll catch up with you in a second. All right, so let's see how we do this. So if I go ahead and distribute, I have a negative 2x, a negative 6, that's over 4 is equal to 8 and 6. Okay, so there's a couple different ways we can do this. And I think we should think about what is happening to x. So the first thing happening to x is times negative 2, then minus 6, then divide 4. So the opposite of divide 4 is times 4. So if I go ahead and multiply by 4, multiply by 4, multiply by 4, this goes away. So I'm left with negative 2x minus 6 equals. Now, 8 times 4, that's 32. 32 over 6, that does simplify. But I'm not super worried about that at the moment. Let's go ahead and keep going. And we're probably going to have to make use of our calculator a little bit to kind of help us. So adding 6. Let's go ahead and switch to our calculator. And so we have 32 divided by 6. And we're adding 6. Whoops, that's not going to work. I got to get out of that fraction there. So plus 6. And I want a fraction. So that's giving me 34 over 3. So I have negative 2x equals 34 over 3. Okay, so going from there, now I'm dividing by 2. So divide by the negative 2, divide by the negative 2, which means I'm really drawing a line like that. Well, how do I take a fraction and divide by 2? Well, if you remember, you can't really divide fractions. You actually have to flip and multiply. So this is 34 over 3 times 1/2. And remember, we multiply fractions across the bottom and across the top. So that would give me 34 over 6. And I'm not done yet because that's not simplified. So I noticed that both of those are even. I'm going to divide by 2. That's going to give me 17 over 3. So there's my answer. X is going to equal 17 over 3. So keep in mind that your calculator can help you with those fractions. There is no reason why you can't apply your inverse thinking, even if we're looking at two fractions. All right, let's keep going and let's move on to our new stuff today. So as we talked about, we want 2 and 2 before we start moving things over. And what we want is we want the variables on one side, the numbers on the other, or the numbers and the variables, okay? So it doesn't make any difference if the letters are on the left or the letters are on the right, the variables. You just need to be consistent and get all of them on the same side, okay? So all the like terms need to be gathered to the other side. I personally like to have my variables on the left. So I'm most of the time going to be moving things to the left. There will be the random case where I'm going to move them to the right, but for the most part, I'm going to move them to the left. So that means I'm going to start by moving this 5x. Well, I notice it's a positive 5x, so the opposite is going to be a negative 5x. This is gone. 2x minus 5x is negative 3x. Now looking at what I have for steps there, I notice that that is times negative 3 plus 7. So opposite is going to be minus 7. So negative 3x is going to equal 9. And then dividing by negative 3, x equals negative 3. Why don't you go ahead and take a minute, hit pause, see if you can solve the next one. All right, let's see how you did. So I'm going to go ahead and start by moving this negative 5x. Opposite, positive 5x. 2 and 5 is 7. And if you don't need to write this anymore because you understand what the inverse operations are, then don't write it, okay? It is totally okay to start kind of skipping some steps now. So minus 3, this is gone. I have a negative 18. I'm dividing by 7. X is going to equal a negative 18 over 7. And that one is done. It is not going to go any farther because 7 is prime. Okay, now let's take a look at this one. So this one actually has 2 and 1, but there's still a problem. I have these x's, okay? Now, I could move this 7x to the left by adding. And I have 15 plus 5x equals 0. Because something is still over there on the right. But then I have to move the 15 to the other side. So that seems like it would be defeating the purpose of trying to have the variables on one side and the numbers on the other. So in this case, I'm going to move the negative 2x this direction. So positive 2x. So 15 equals negative 5x. And go ahead and take a minute and finish that one. Divide by negative 5. X equals negative 3. And if you were able to go from here to here without writing that step, that is perfectly fine. At this point, many of you should be able to start skipping some steps. All right, take a look at the next one. Go ahead and start it and see what you can do. Okay, let's see how you did. Remember, distribute and simplify. Those are two things that we always keep in mind when we're solving equations. So we have negative 5x and a negative 10. Now over here, that's a negative 1. So I have 2, a minus 1x, and a minus 4, because negative 1 times x and negative 1 times 4. And then, look at that, I have like terms again. So I'm going to be combining because there's 3 things over here. Remember, I need 2 and 2. Okay, 2 terms and 2 terms. So negative 5x minus 10 is going to equal a negative 2 minus an x. Okay, take a minute, see if you can finish it up. Okay, I'm going to add my x. So I have a negative 4x minus 10 equals a negative 2. I'm going to add 10. And I come up with 8. I'm going to divide by 4, and that's going to give me 2. So again, it is absolutely okay to start skipping a few steps here. Not an issue. Most of you should be able to start working through these without writing every single step down. All right, go ahead and pause and work on these 2 problems. Let's see what you come up with. All right, here we go. 5x plus 5 equals 15x minus 12 minus 10x. Okay, combining terms. I have 5x plus 5 equals 5x minus 12. All right, now I'm noticing something here. These are both the same. So I'm going to subtract 5x. These are gone. What happens right there? All of a sudden, I have a 0x, okay? A 0x. And that is a big flag for me, okay? That is a big flag for me that something is going on. And what I'm left with is a positive 5 equals a negative 12. So here's where you have to make a decision in terms of whether this is true or whether this is false. Okay, and I want to pull you back to the numbers tricks things that we did day 1 of this chapter, where we, like, I picked 7 and you picked 5 and we all came up with the same answer of 0. Or you picked a 3 and then when you solved the entire problem, your answer was a 3. There are special types of equations that have specific or special answers. So we already know that on equations, we can come up with one solution, okay? So on equations, I can come up with one solution. That is your normal problem. Then we also have some that are no solution. There are no numbers that make those work. There's no answer, okay? And then we also have infinitely many, or this double-legged R, which stands for all real numbers, okay? Infinitely many, or the double-legged R, which is all real numbers. So this one, 5 is equal to negative 12. Well, that is definitely false. Well, if it's false, which one do you think it is? Do you think it's one solution? Can't be one solution because I have 0 x's. Impossible. No solution or infinitely many? Well, no solution means it wouldn't work. So it would make sense that if it's false, this is a no solution. Okay, that's a no solution. All right, take a look at the next one. Let's see what you did there. So 6b minus 3 minus 7, 6b minus 10. If I keep going, 6b minus 10, those two are like terms, and 6b minus 10. What do you see right here now? Do you see how these are exactly the same? Okay, they're exactly the same. So that means if I subtract my 6b, there's my 0b. Okay, that's going to flag that I've got either no solution or infinitely many, and I'm left with negative 10 equals negative 10. Notice that that is definitely a true statement. Okay, so that one is our infinitely many, or all real numbers. So this is the problem where in our numbers tricks that we were working on that first day, like everybody picked a different number and we all came up with a 0. That is an infinitely many problem. No matter which number we pick, we come up with the same answer. Okay, so you can have those special case scenarios, but the problems solve exactly the same way. So as you're working on homework tonight, you will see some no solution. You will also see some infinitely many. So remember, no solution are going to be the ones that you have 0x or 0y, and they're not the same. And infinitely many is going to be the ones with 0x, 0y, and they are the same. They are equal to each other. So the infinitely many is true. The no solution is false. All right, you're ready for homework. I'll catch you tomorrow.